Welcome to qnawire.
To solve this problem, we need to use the concept of conditional probability in the binomial distribution. So let's let event A be the event that the computer has a virus. Event B, the event that the computer does not have a virus. Event C is that the virus detection program believes the computer is infected. And we'll let D be the event that the virus detection program believes the computer is not infected. From the problem, we have the following probabilities. The probability of A is 0.65. The probability of B would be then 1 minus 0.65 or 0.35. The probability of C given A is 0.8. The probability of D given A would be 1 minus the probability of C given A, which would be 0.2. The probability of C given B is 0.1, and the probability of D given B would be 1 minus C given B, which is 0.9. We also know that there are 12 virus detection programs, and we need at least 9 out of the 12 programs to agree on the computer status to trust their verdict. So we want to find the probability that 9 or more programs believe the computer is infected, given that the computer has a virus. This follows a binomial distribution with n equals 12 and probability of success being 0.8. So we want to find the probability that x is greater than or equal to 9 given A, where x is a binomial distribution. This would be equal to 1 minus the probability that x is less than or equal to 8 given A. And this would be equal to 1 minus the sum from k equals 0 to 8 of 12 choose k times 0.8 to the k and 0.2 to the 12 minus k. Case 2, the computer does not have a virus, and that's the probability that y is greater than or equal to 9 given b, which would be 1 minus the probability that y is less than or equal to 8 given b, which would be 1 minus the sum from 0 to 8 of 12 choose k times 0.1 to the k times 0.9 to the 12 minus k. And so the probability of a correct decision would be the probability of A times the probability that x is greater than or equal to 9 given A, plus the probability of B times the probability that y is greater than or equal to 9 given b. Alright, so now I'm going to get into a calculator here. We know that the probability of A is 0.65, and the probability that x is greater than or equal to 9 given A, I'm going to put that into a calculator binomial distribution with a probability of, with 12 trials, and the probability of success being 0.8, and we want greater than or equal to 9. That's 0.7946. The probability of B is 0.35. And the probability of Y being greater than or equal to 9 when the probability of success is 0.1. Is, well, I'll just do 1.658 times 10 to the negative 7. It's very, very small. Okay, so we multiply that by 0.35. And then add to that 0.65 times 0.7946. You get 0.5165. Or a 51.65% chance of making the correct decision.